Hey everyone, Mr. Scullin here. We are back at it for lesson 5 in unit 5, and today we're going to be doing a couple different things here, and we're going to be talking about converting between exponential and radical forms with rational exponents, and this is really going to be our key focus, rational exponents. What does that mean? Rational, big fancy math word for fraction. So when you start to look at your paper, you're going to see all your exponents have fractions as their exponents. Okay, so let's dive right into it here. I'm gonna try to show you a couple different ways to do each problem, if it allows. And what I don't want to do is overcomplicate it, but I do want to show you some of the options that you have when you work through some of these, because everybody's brain will absorb this a little bit differently, and you got to figure out what works best for you. Okay, so let's take a look at the first slide. You have these two, and it says try it with your graphing calculator. So go ahead and hit pause, or a regular calculator. Go ahead and hit pause and try those, and then we'll come back here in a second. Okay, so if you have your calculator, you may or may not know how to do a fraction in your calculator. So I'm going to show you with the scientific here, if I can get the glare off. There you go. So what you would do is you just hit 25, and then you would hit your caret button, which is the upside down V. And then I usually use parentheses, so open parentheses, and you would just hit 1 divided by 2 for the 1/2 and hit equals. And you'll notice that you get 5. So we would just put 5 here, and everybody's happy, all right? And then over here, we have the cube root, or excuse me, the 1/3, kind of Freudian slip there, kind of gave away the secret. You have 27 to the 1/3, so 27, power button, parenthesis, 1 divided by 3, and hit equals, and you get 3. Now with your graphing calculator, it's the same exact thing. If you have your graphing calculator here, you still have a caret button, and so you can do the exact same thing. 25, caret button, 1 divided by 2, hit equals, and you're going to get 5. Now, you should see something a little fishy here, right? 25 and 5, what relationship does 25 and 5 have? We know the square root of 25 is 5. We know the cube root of 27 is 3. And so what you're going to learn here with rational exponents, which means your exponent that's a fraction, is the bottom number is the index, and the top number is the exponent, okay, or the power. So when you have 25 to the 1/2 power, that can be rewritten as the square root of 25. Sometimes you see it like that, 25 to the 1st, or you can express it like this, the square root of 25, and you can put the whole thing to the 1st power. Well, we know the square root of 25 is 5, and 5 to the 1st is 5, or 25 to the 1st is 25, square root of that is there. Likewise here, I'll do it in red. 27 to the 1/3, that means 3 is the index, which the index goes right there. 27 to the 1st power, right? The cube root of 27 is 3, 3 to the 1st power is 3, or you can write it as the cube root of 27 to the 1st power. 27 to the 1st power is 27, cube root of that would give you 3. And so on the second page here, I kind of show that to you, so if you want to refer back to it later, you have the index, the exponent, and the base, which translates into this. We will at times ask you to go this way as well, right? So if I gave you a problem like x to the 7/5, how would you convert that into having a root? Well, the bottom is the index, so that would be the 5th root of x to the 7th if you wanted to convert that. For the most part today, we're going to be going from rational exponent form into root form, okay? All right, so let's try a couple of these real quick. You don't really need a calculator for this, but if you'd like one, you can. I'll do it in pencil here. So you're just going to have to get used to this. I'll write it both ways. So we can go 32 would be our base. It's going to be the 5th root of 32, and that is going to be cubed. And so you can write it like that. So the 5th root of 32, you should know that by now, hopefully, maybe you don't. But if you need to put it in your calculator, you can. But I want to try to do these by hand. What times what is 32? That's 2, but to the 3rd power. 2 times 2 is 4 times 2 is 8, so we get 8. Okay? If you wanted to, you could also express it this way. The 5th root of 32 to the 3rd power. So if you had your calculator out, you could go 32 to the 3rd power equals that big number, and then raise that to the 1/5. 1 divided by 5 equals 8. Okay? And so you can see you're going to get it either way. All right. Go ahead and try this one on your own, and then hit play when you have successfully tried it. Okay, so remember the bottom number is always the index, so that's going to be the square root of 25. Top number is the exponent to the third, so we know the square root of 25 is 5, and 5 cubed is 125. Or you could go the square root of 25 to the third, so 25 to the third power is this number, so it's basically the square root of 15625, and then you can take the square root of that, second answer, and still get 125. Okay? Most students are going to go down usually this road right here, these two examples that I did, but again, you can also do it this way. Okay? All right, let's try some more challenging questions here. So we have a negative, again, bottom number, same thing. It's the fifth is the index, negative 32, and that's to the fourth power. So the fifth root of negative 32, we just did a problem with the fifth root of positive 32. And if you need to, you can grab your calculator, right? You could go parenthesis negative 32, and it's important to make sure that parentheses on the inside, or the parentheses around the negative 32, okay? Raise it to the 1/5, right? We're learning that if you take the fifth root of something, it's the same thing as, the fifth root of x is the same thing as x to the 1/5. Probably should have put this on your front piece of paper, but it's the same as 1/4. If you have the cube root of x, it's the same thing as x to the 1/3. Those things are the same. Whatever the index is what the power is. So I could go to the 1/5, hit equals, and I'll get negative 2, and then I'm going to put that to the fourth power, which would be 16, right? So that's our answer for that one, 16. Feel free to hit pause and rewind anytime you'd like. Take you a little while to get used to these, but you can do it. Okay, so here's where you kind of have two options. I'll kind of draw a line in the middle here. This is the index, right? So it's the fifth root of negative 32, y to the 15th, all to the first power. In other words, we're taking the fifth root of negative 32, which we just did to be negative 2, and the fifth root of y to the 15th. Well, remember that we talked about this. Whatever that exponent is 15, we divide here. Works out nice. We just get y to the third, and that would be our answer. The other way to do this, I'll put the or right in the middle, is remember that there is technically a time sign in between, right, there. So some students will do this, negative 32 to the 1/5. They'll take this 1/5 and distribute it times y, and then 15 times the 1/5 would just be 3. And so you just take negative 32 to the 1/5, which was the fifth root of negative 32, times y to the third, and we get negative 2y to the third. So that's another way you can do that problem. Knowing that, I'd like you to try both of these. You can do it whatever method you want to do it. Try it and see what you come up with. Okay, if I was doing this problem here, I looked at this negative exponent, and I'm definitely going to take this negative 12, and I'm going to times it by the 2/3 and times it by the negative 1/6. So when I do that, I end up getting x. Negative 12 times 2 is negative 24 over 3, and then y to the positive 12 over 6. And then we just want to reduce those fractions, right? So we get x over negative 8y squared. And since we have a negative exponent right here, only that moves. The y squared stays on top, and we get something like this for a final answer. Okay. On this one, I may go a different route, and it's just, again, having some number sense and getting used to this, and it may take you a little while to get to that point. But what's anything to the 1/2 really mean, right? We talked about this up here. I didn't finish it. If there's just, we never put a 2 here, but a square root is anything to the 1/2. Just a normal square root, right? 5, 4, 3, there's really 2 there, but we never put it there. So when I look at this, I see, oh, that whole thing's to the 1/2. What does that really mean? It's the same thing as this whole thing being square rooted. So it's really 16x to the 14th over 81y to the 18th, and it's just a giant square root. Well, we know how to do that, right? Remember, we can take the square root of the top and the square root of the bottom. Square root of 16 is 4. Square root of x to the 14th, 14 divided by 2 would just be 7. On the bottom, square root of 81 is 9. 18 divided by 2 is 9. And there's your answer. Okay? You could have, if you wanted to, have taken this 1/2 and gone 16 to the 1/2. Take 1/2 times 14, which would be x to the 7th. And then that 1/2 would also have to go on the bottom, 81 to the 1/2. That 1/2 would have to get multiplied by that and get your 9. and then simplify from there, right? 16 to the 1/2, basically the square root of 16 is 4x to the 7th, 9y to the 9th, and you get the same exact thing, okay? So I know it's a little different, but once you get the hang of it, the most important thing is just remembering this right here, and you should be in good shape. If you know the bottom number is always the index, and that's the power of the exponent, you should be rocking and rolling. Once you do a handful of these, you'll get used to it pretty quickly, okay? If you have any questions, as always, I'd be happy to help you out in class, and we'll see you then.